Assalamu alaikum warahmatullahi wabarakatuh. Good morning, dear students. Today we are going to discuss the evidence of evolution, lesson number 3 in that chapter. And we are going to use the two terms of fossil and fossil record as keys to enter the lesson for how do fossil form and how did they change over the time. Let's start. Okay, on page number 30. How do fossils formed? That's the first question that we need to answer to log into the lesson. I need you to take a look to these two photos here. That for amber, and this one for a specific fossil called Archaeopteryx. Later we're going to specify what does it mean that and what is it exactly. But how do fossils form? We need to answer that question. Well, if we can read about that lesson, starting from how the fossil formed, but evidence that organisms have changed over time can be found in amber, ice, or sedimentary rocks. Well, the sedimentary rocks is formed when particles of sand or soil are deposited in horizontal layers. So this is happening by depositing layer above each other from sand above each other to form the layer. Often this occurs as mud or salt hardens. After one rock layer forms, the other layer rock will form on the top of it, so the older layer are found below or underneath the younger rock. Well, the most basic principle of dating such rocks and the remains of organism inside it is, the deeper it is, the older it is. Well, here amber fossil form when a small creature are trapped in tree sap and the sap hardens. I need you to take a look to that photo. You will notice that even the soft parts, the skin and the hair and the wings, remain or preserved inside the amber, but we can say that nothing changed, almost not changed. And in the other photo, this flying dinosaurs is an example of a cast fossil. But actually that cast fossil explains what happened to the Archaeopteryx and the transitional stage between the reptiles and birds. I'm not saying that reptiles did change to fly. I'm not saying this. That is not the concept of evolution. Whether I'm convinced about it or not, that is not the truth. I'm not saying that reptiles that fly later, but I am saying that this is a transitional stage between the reptiles and bird. We can say this fossil was exist as a creature, as a species, not it's adapted to do something like that. Well, actually a reptile will never fly a day. In this question number 5, examine what feature of this organism are preserved in amber. I need you to take a look and tell me about the answer. Well, exactly, the amber preserved all of an organism's feature, even the soft bodies, the soft parts, wings, and even the skin and the hair. Okay, so the answer of that question is supposed to be the amber preserves all of an organism's feature, even soft bodies, part, and wings. Okay. Now we got many fossil form in sedimentary rocks, and we said before what does it mean sedimentary rocks. Now let's talk about the fossil that formed inside the sedimentary rocks. Well, we can say that rocks layer preserves evidence of organisms that were once alive, and the remains of imprints of once living organisms are called fossils. So fossil commonly form when a dead organism is covered by a layer of sediment or mud. That is now a definition for fossil. Now we can define the fossil with these two sentences. Again, rock layers preserve evidence of organisms that were once alive. The remains or imprints of once living organism are called fossil. So fossil commonly form when a dead organism is covered by a layer of sediment or mud. And over the time there's going to be some changes occurs to the creature that lives inside that sedimentary rocks according to the features that the organism is going to have, something like wings, something like the skin, the hair, other features, even the body, the structure of the bones. We are going to discuss this later. Now, how do fossils show change over the time? I need you to take a look to that photo. Pause the video, take a look, read that part, then we are going to proceed. Well, naturally, all of the fossils that have been discovered make up the fossil record. There's another term here, a fossil record. What does it mean? Well, the fossil record provides evidence about the order in which the species have. So, again, all of the fossils that have been discovered make up the fossil record, and the fossil record provides evidence about the order in which the species have existed through time. Okay, and how they have changed over the time, that occurs by nature. By examining the fossil record, the scientist can learn about the history of life on Earth. But despite all the fossils that have been found, there are gaps in the fossil record. The gaps represent the chunk of the geologic time for which a fossil hasn't been discovered. Now, let's go again to that photo. What that represents, as I said before, but not for the same organism or the creature, it's a transitional form between fish and four-legged land vertebrates, another element that live in land. Maybe this creature called, try to spell it, Tiktaalik rhizia. Yes. Take a look to the part that here in the ground and the part that still inside the water. You will find that there are some changes. We're calling a kind of structural adaptation. We cannot say that that part that remains in water looks like the other part that here in the ground. We can say that in the ground the animal adapted or developed a new fin that looks like the hand to make the animal able to move in the ground, but the other part that here in the sea, inside the water, that lives in the water, but actually there is no need for something like that. Just a tail will do just fine. So the question here says, describe the environment in which this organism lives. Well, simply the organism lives on the edge of a body of water and possibly on both water and land. Can we consider the creature an amphibian? Yeah, now we are going to talk about the evidence of evolution. Now the creature did, I'm not going to change this, I'm not going to say it changes the species, but in the same time it has a structural adaptation. Okay, for question number 7 again, identify. Describe the environment in which this organism lives. Well, actually it lives in both water and land. Question 8. How is this organism like both a fish and four-legged vertebrates, such as an amphibian? Think about the answer. Well, simply the organism has a tail and fins like a fish, but lives above water like a four-legged vertebrate. And also in that case, it developed a new type of hands or fins to make the animal able to move or live the ground. So the answer again will be for question number 8. The organism has a tail and fins like a fish, but lives above water like a four-legged vertebrate. Okay. What other evidence support evolution? Well, before reading about that part and the common structures, we're going to say something, that the different structure here for the hands supposed to be exactly a kind of structural adaptation. We are considering such kind of adaptation or change in the body as an evidence of evolution. We didn't, we can say, remain as the former structure for our body. We can say that the animal or the organism finally is going to change and develop according to what it needs to adapt to the surrounding environment. Good. For the common structure here, what exactly we are going to mention about that part after seeing these photos for the hands? Well, normally the scientists have found that related organisms share structural traits, and the structures reduced in size or function may have been complete and functional in the organism's ancestor. Father and mother, let's find out. For example, snakes have traces or leg-like structures that are not used for movement. These unused structures are evidence that snakes share a common ancestor with the animal, like lizards and dogs. A minute. We can say that the structural adaptation in that case takes the form of an evidence of evolution. Well, exactly, that's right. Okay. Well, continue with common structure. We can say that scientists here also consider similar structure with the different function in the arm of the human and the front limb of a cat and bat. These three photos. The arm of a human, the front leg of a cat, and the wing of a bat do not look like and are not used in the same way, but as you can see, they are similar in the structure. The bones of the human arm are similar in the structure to the bones and the front limbs of a cat and bat. These similarities suggest that cats, bats, and human had a common ancestor. But over millions of years, a change occurred, and now these bones perform different functions in each type of animal. Now let's go to question number 9. That question. But the question here discusses the part that we just read before. What is the common ancestor? What does it mean, a common ancestor? Well, simply, a common ancestor is the most recent species from which two different species evolved. So a common ancestor, it is the last one, the most recent species from which two different species evolved. Okay, at that part, we reach to the end of our lesson today. Hope that you enjoyed this session and wish to see you next time. See you.